This video is covering section 1.4 on exponents. The goal of this video will be to review the laws of exponents to be used to solve exponential equations in a future section. All variables in this block are going to represent real numbers, and any variables in the denominator are non-zero. So remember that when you multiply like bases, the bases do need to be the same. You can add exponents. When dividing like bases, you will subtract exponents by taking the exponent of the numerator and subtracting the exponent of the denominator. When you're raising a power to another power, you will then multiply the powers together. And when you are raising a product to a power, the power will distribute to both of the factors. If you're raising a quotient to a power, the power will also distribute to both of the factors. Any number other than 0 raised to the 0 power is 1. When we want to deal with negative exponents, if it is negative in the numerator, we move the entire quantity, the base and the exponent together, to the denominator and make the power positive. Again, provided that the base is non-zero. And then dealing with fractional exponents, it's the denominator that becomes the root of the radical. If the numerator of the rational exponent, rational meaning fractional exponent, is anything other than 1, that becomes the power on the base. So for example, if this said x to the m over n power, this would be the nth root of x to the m power, or you could write this as the nth root of x quantity to the mth power, provided that x is non-zero again. Let's take a couple examples. So we want to simplify each expression and rewrite without negative or fractional exponents. When working on the homework, just make sure to read the directions first before submitting your answer, as the directions will change a little bit. So we still want to make sure to keep in mind our order of operations. I like to refer to them as GEM-DOS instead of PEM-DOS. So GEMD-AS. And then the G for me is grouping. So grouping symbols like parentheses, but not just parentheses, brackets, braces, anything that groups them together. And then we know E is exponents, M is multiplication, D is division, and then addition and subtraction for that A and S. So considering that, when we look at our first example, we'll want to do exponents first, and then we'll do the multiplication of the numerator, and then we'll divide by the denominator to make sure we follow those order of operations. So the quantity, because 4 and x are both in parentheses, they're both going to be raised to the power of 2. So if we use that rule, we have 5x times 4 squared and x squared over 2, and just the x's squared in the denominator. So 4 squared is going to be 16. So we have 5 times 16 times x squared all over 2x squared. 5 times 16 is 80. And then when we multiply like bases, the x times the x squared, we're going to add those exponents together, and it's going to be 3. That's because this x has a power of 1. So 1 plus 2 would be 3, and we're still dividing by 2x squared. 80 divided by 2 is going to be 40, and then x cubed divided by x squared is x to the 3 minus 2, or just x. Now we want to rewrite the second quantity in part B without fractional exponents. So we want to rewrite this as the radical form like we did in the previous slide. And so notice though that there's no parentheses here, so it's only the x that's being raised to that power. And so the 5 is going to stay outside of the radical. And so in radical form, we're looking at square root, because the 2 is in the denominator, of x cubed. Or alternatively, this could be 5 square root of x quantity cubed. The next video is going to cover quadratics.